All right, so here's the other half if you wanted to get some extra examples. So again, for these ones, we're supposed to solve, but we don't have a specific way to solve, and we'll need to come up with that. All right, so looking at A, just because there's one term that has an x and it's being squared, I think the easiest way to do this would just be to solve by using square roots. So we could just subtract 25 from both sides. So we'd have x squared is equal to negative 25. And then we would square root both sides, just remembering that when we square root both sides, we have a plus or a minus. So we have x equals plus or minus the square root of a negative. Well, that's just I. Okay, so that could give us I square roots of 25, or the square root of 25 is just 5. So it'll just be x equals plus or minus 5i. Okay, and that's fairly straightforward. I mean, you could use, really the only other way you could do this would be, I guess you could do like the sum of squares, and we kind of learn that kind of stuff. You could do that, but I feel like this would be definitely the easiest for that problem. Okay, for B, looking at that, I'm not sure if factoring would work, but I know that completing the square would, because A is 1 and B is even. Okay, so that's probably what I would just go for. So I'm going to give that a try. I'm going to move the constant to the other side. That would give me x squared plus 16x is equal to 15. To complete the square, you have to make sure you do it to both sides. It's going to be half of b, and we'll square it. So half of 16 is 8. 8 squared is 64. So we would add 64 to both sides. Now we can write that as a binomial squared because this is a perfect trinomial. Okay, so it'll be x, and then half of b would be 8. Okay, or you could do glasses and you'd get the same thing. On the right side, looks like that would give us 79, if I'm right. Okay, yeah. And then we will solve by using square root. So square root, plus or minus. So we get x plus 8 is equal to plus or minus the square root of 79. Okay, and I think that's prime. You could try and do a factor tree. Square root of 79. Okay, I think that's it. And then all we do last is to divide 8 to both sides. So our answer would be x is equal to negative 8 plus or minus the square root of 79. Okay, and looking at that, I think that was a good choice, because there's no way that these would be your two choices to multiply and add. So we wouldn't be able to do factoring for that problem. All right, here's another example. We wouldn't use completing the square because a is not 1. We wouldn't use solve by using square roots because we have two terms with x's. So either this is going to factor or we'll use the quadratic formula. So either way, we'd need to move this to the other side by adding 3 to both sides. So we get 2x squared minus 13x plus 15. We could try and do glasses. That would give us, what, 30x squared, and it needs to add up to give us a negative 13. And I think that would work. So for 30, we could do negative 10x minus 3x. That multiplies to give us a positive 30 and combines to give us a negative 13x. So a is not 1, so we'd need to do grouping. So 2x squared minus 10x minus 3x plus 15. And we would cut it in half. Greatest common factor for the left side, looks like it's a 2x. And what's left after we divide everything would be x minus 5. And then we could factor out a negative 3 on that side. And that leaves us with x minus 5. So we got that right. Last thing, we would factor those out to the front, so x minus 5 times 2x minus 3 is equal to 0. And then we'd use the zero product property. So since those two parentheses are being multiplied, we would want to say that either x minus 5 has got to be 0 or 2x minus 3 has got to be 0. And we'd solve for x. So add 5, x equals 5. And we could add 3 and then divide by 2. So 5 or 3.5. Okay. Again, you could use the quadratic formula for that. And I don't know, maybe you feel like that would be a better choice. Okay. All right, D. Again, we need to make sure everything's on one side. So we already have a 2x squared. We're going to subtract 10x to both sides. So minus 10x plus 12 equals 0. We could divide both sides, or we could factor out a 2. 2 is x squared minus 5x plus 6. And we could try and see if factoring would work. We can't complete the square because A here isn't 1 and here B is not even. So we wouldn't complete the square or use solve by square roots because all the same reason we said before. Okay, so we'd maybe try glasses. So 6x squared adds up to give us a negative 5x. That's tricky. So if we did 6, we'd have to do 1 and 6 or 2 and 3. So the only way you could get this to give us a negative 5 is if we did like 1 minus 6. But if you multiply, that would give us a negative 6. So that doesn't work. 2 and 3, the only way you could get that to work is if you did negative 2 minus 3. And that would work. Okay, so we'd have negative 2x minus 3x. And since we took out the greatest common factor, it looks like we could use the shortcut, so x minus 2 and x minus 3. And again, we use the same thing we just talked about, the zero product property. Either x minus 2 is 0, or x minus 3 has got to be 0. So we could add 2, add 3. So x is equal to 2 or 3. All right. All right, let's check this one out. Always need to move this over. So x squared minus 6x plus 38. Okay, could try and see if factoring would work. So 38x squared, and the middle term is negative 6. I don't think this is going to work. We could complete the square. For 38, we could do 1 and 38, 2 and 19. 3 doesn't, 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't. I think those are our only choices. So factoring's off the table. That doesn't work. But we could complete the square. So that's what I'm going to do. I'm going to move that 38 over to the other side. And I'll complete the square. So to complete the square, it's always half of b, and we square it. So we would add 9 to both sides. Write it as a binomial squared. It's always half of b. This gives us a negative 29, I think. Okay, and then we'll square root both sides. X minus 3 is equal to plus or minus. Negative inside will give us an I, square roots of 29. And the square root of 29 is prime, so we can't, or at least we can't simplify it. And then the last step would do is to add 3 to both sides. So our answer would be 3 plus or minus I squared, so 29. And then last but not least, since we haven't done any, like a lot, we haven't really done any of the quadratic formula ones. Let's just do this one as a quadratic formula. Perhaps the others would work, but we're going to subtract that 20 over. So we get x squared plus 11x minus 20 is equal to 0. We'll label A equals 1, B is 11, and C is negative 20. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so again, to simplify, we'll simplify what's inside the root, so the discriminant. That's 11 squared minus, and always put in the parentheses just how you write it, even if you think you got it. So negative 4 times 1 times a negative 20. So that gave me 201. So x equals negative 11 plus or minus the square root of 201 over 2. Okay, and 201, I'm just going to tell you, is prime, so we can't simplify that. Okay, and then we could try the fraction. Again, we look at all three of them, and since we can't divide all of them by something except for one, we're all done. Okay, so I think that was actually a pretty good choice. I don't think we could have done that using any other method. All right, well, if you have any other questions or concerns about this homework, let me know. We'll be reviewing next time and probably the next. Okay, we'll see you guys.